Right, so today we're going to be looking at zero and negative exponents. So what does it mean when you have a zero in the exponent or you see that there's a negative number there? What do you do in those cases? I'm going to do a problem two different ways. And what I'm going to do is I'm going to show you how I calculate this just numerically. And then I'm going to use the rules that we learned recently to calculate this one or simplify it. And then I'm going to see how these two answers compare and then obviously make the ultimate conclusion that they must be equal. So 5 times 5 times 5 I know is 125. Same thing here, 125. And anytime you have the same number divided by itself, you're going to get 1. So that's my answer there. Okay. Now over here, I have 5 to the third divided by 5 to the third. I'm going to use a property we recently learned, which was the quotient of powers. Quotient of powers says I'm able to take the exponent in the numerator and subtract the exponent of the denominator. And now that leaves me with 5 to the 0 power. Now, if I get 5 to the 0 power, and I'm starting with the same exact problem, if I know for sure that there's no mistakes here, that that's equal to 1, then therefore, by default, this must also be equal to 1. Because we calculated this here, we know for sure that that's equal to 1. And if we have this expression here that we know comes from the same problem, then that must be equal to 1. Okay? So let's go ahead and write down the 0 exponent property. Which says that if you have a to the n power, sorry, a to the 0 power, it's going to always equal 1. Where a cannot be 0. Okay? As long as your base number is not 0, then you're good. So for example, let's say you have 4 to the 0 power. Well, if it's got a 0 exponent, it's going to be equal to 1. Okay? As long as this is not a 0. So now let's look at what happens. Well, let me tell you in words. Let's say this is states that any number, we'll call it A, except 0, when raised to the 0 power There you go. Okay. So now let's observe what happens when we have, observe our place values. So say I have 1,000, then I have 100, then I have 10, then I have 1, then I have 1/10, then I have 1/100th, 1,000th. Okay, those are my place values. Now, why did I write these? Because we're going to rewrite them as exponents. So if I have 1,000, that's the same as 10 to the 3rd power. And if I have 100, that's the same as 10 to the 2nd power. And 10 by itself is 10 to the 1st. And we just learned that anything to the 0 power is equal to 1. And if you notice what's happening to our exponents and we continue the pattern, 3, 2, 1, 0. So the next one is 10 to the negative 1. Then you have 10 to the negative 2 and 10 to the negative 3. Okay, now, why is this important? Well, I just did progressively, went through the place values that we already know from elementary school. And with those place values, you're able to see that exponents can be used. I'm going to rewrite this one as 1/10 can be written as a fraction, 1/10. And 1/10 we just said is equal to 10 to the negative 1. This one is also said as 1/100th as a fraction, 1/100th. And that also can be written as an exponent of 10 to the negative 2. Okay? And then this one is said as 1/1000th, 1 over 1,000. And that can be written as 10 to the negative 3. So, most importantly right now, we want to focus on this. Okay? 10 to the negative 3 means 1/1000th. 10 to the negative 2 means 1/100th. Now, what's the correlation between the ones with positive exponents and the ones with negative exponents? Well, let's take a look at 10 to the third versus 10 to the negative third. What do you notice? 10 to the third is 1,000. 10 to the negative third is 1,000th. Let's look at 10 squared versus 10 to the negative 2. 10 squared means 100, and 10 to the negative 2 means 1/100th. Now, what do we call a number when you flip it? What's that word that we've used? Reciprocals, right? What's the reciprocal of 1,000? 1 over 1,000. What's the reciprocal of 100? 1 over 100. What is the reciprocal of 10? 1 over 10. So that's all it does. Exponents with negatives literally just mean you're taking them to be the reciprocals. So let's go ahead and write that down. Negative exponents so if you have a to the negative n power, it's equal to the reciprocal of whatever a to the n was, where a is not equal to 0. Okay. So when I see this, and it's very important because I try to think of a way that makes this easier to apply, to understand. When we think of reciprocal, we think of a fraction where the numerator and denominator switch places. So if we have to think of the reciprocal, then I need to make sure that I think of this as a fraction. So I did that in pencil. And if I see this as a fraction, that negative is telling me that it's not happy. Okay? I think of negatives as being something bad, and it's not happy. A to the n is not happy where he's at. So I'm going to just put on here that the negative means not happy. Okay? And that's just my little story because it helps me get this point across to students. The negative means he's not happy where he is. Okay? Not happy where he's at. So a to the n is not happy on the top, right? If he's in the numerator. Then what should we do to make him happy? Then he must want to be on the bottom. So that's why a to the n ends up on the bottom. Notice the negative is not there anymore because he's happy. He's happy where he's at, okay? That's a simple story. I know it's kind of silly, but it will be helpful in remembering the rules and the process for this. And if you mathematically think of this as reciprocals, then that's exactly what it is. So let's go ahead and write that part down too. For any number a, except for 0, a to the negative n is the reciprocal of a to the n. Now, the reason I told you this little story is because sometimes you're going to end up with a negative exponent that is already in the denominator. And then that whole reciprocal thing kind of confuses a lot of students. So just think of it as if it's negative, it's not happy where it is, and we need to move it somewhere else. And there's only two places, numerator or denominator. All right, so now let's look at an example and apply this rule. And I will interchangeably speak, the mathematical definition of being the reciprocal, and then I'll also mention the little story to help you remember why it is we're doing what we're doing. Okay, so now let's look at an example. Example 1 has a couple parts, so we'll start with example 1a. And example 1a says 3 to the negative 4th. All right. The story that I just told you was, if you see a negative, it means it's not happy where it is. But we have to acknowledge that we need a numerator and a denominator. So right now what I'm going to do, I'm going to add a denominator. Okay, now it looks like it's in the numerator. And I can see that it's negative. That tells me that 3 to the 4th power does not want to be there. It wants to be somewhere else. So where else could it go? To the bottom. Right? Put it in the same color. So if 3 to the 4th is not happy up there, then he must want to be down here. And we'll put a space holder up there. And that's all you have to do. Notice that the negative is not there anymore. I did not rewrite the negative because he's already happy, right? So we don't need to put the negative down. So that would be 3 to the 4th would be 3 times 3 times 3 times 3, 9 times 9, 81. All right? And again, what does it really mean mathematically? It means we are going to rewrite 3 to the 4th as its reciprocal. 3/4 in the denominator, okay? So again, it is still the reciprocal, but either way you want to think of it will get you the right answer. Let's look at example B. We have negative 8.5 to the negative 4 power times negative 8.5 to the 4th power. Now, you can do this two different ways, okay? You could observe your power that is unhappy and move it to where it would be happy, or you can observe that you have the same base and you can add the exponents. So I'm going to do it both ways, just to kind of let you see a little bit of both. Over here, I'm going to keep my bases the same, and I'm going to just add my exponents. This is the product of property rule. Oops, add 4. All right, and so negative 8.5 to the 0 power now. And we just learned that any number to the 0 power is equal to 1. Okay? Again, this was product of powers because I have the same base. I have this many negative 8.5s here and this many negative 8.5s here. So combine the total of how many I have. Turns out that I have 0. Now, if you wanted to think of this the way I said it earlier, it looks like negative 8.5 is not happy. Okay, so negative 8.5. Right now, he's actually in the numerator because every single number in math has a 1 under it. Right? And if negative 8.5 is not happy in the numerator, then where else could he go? He must want to be in the denominator. Okay, so I just rewrote this problem, and I just wrote a 1 under this guy. So let's go ahead and make negative 8.5 to the negative 4 happy. I'm going to rewrite him in the denominator. Okay. Now, because he's in the denominator, he no longer has a negative. He should be happy where he's at. Times negative 8.5 to the positive 4th power. There's also a 1 under there. Now, you can cross cancel or you can multiply straight across. When I multiply straight across, I get negative 8.5 to the 4th power divided by negative 8.5 to the fourth power. And when you get the same thing divided by the same thing, you get 1. Okay. Now, which rule was faster for me? Probably this one. Because I already can tell that negative 4 and 4 together give me 0. I remember the rule tells me it's equal to 1. Or take this unhappy power to the denominator, multiply straight across, you end up with the same thing divided by the same thing, which also gives you 1. Or you could have done the subtraction rule, right? 4 take away 4 would give you 0, which is the same thing we had here. All right, and example C. 2 to the 6th power divided by 2 to the 8th power. This rule says, well, it looks like it's division, so I'm going to use a quotient of powers rule. And that rule was to take your numerator's exponent subtracted by the denominator. Now you might feel inclined to do 8 take away 6 because it's easier calculation that way, but you must always start with the numerator's exponent first. 6 take away 8 is negative 2. Okay? And again, I see a negative there. That tells me someone's unhappy. Every number has a 1 under it. So right now, 2 to the 2nd power is not happy in the numerator. It's got a negative. So what do I do to make him happy? Well, if he's in the top, right? If he's in the numerator, he must not like it there. So we're going to make him happy by moving him somewhere else. And that would make him go to the denominator. And now because he's in the denominator, I don't need the negative anymore. He should be happy there. And 2 to the 2nd power is 4. Okay? And that's your answer. Now, again, this is the reciprocal. That's the mathematical term. You take 2 to the 2nd power, the negative means the reciprocal of that. That's why it ends up in the denominator. And that's the rules for negative exponents. Just remember, you see that negative there? Use it to move it somewhere else. All right, so I'm actually going to give you some problems to try. I was not going to do this, but I want you to be able to feel more comfortable with how to do these and have a video going over these solutions. So go ahead and try these on your own, and then you can pause it and then resume when you're ready to see the solutions. All right, so let's go ahead and go over these answers that you got. The first one was 4 to the negative 2. And you can think of this two ways. The reciprocal or that 4 to the 2nd power is not happy. So right now I'm thinking of it as being in the numerator. And if it's got a negative, it means it needs to be somewhere else. So if 4 squared is not happy there, then it means you must want to go down here. And once I've put it in the right place, I don't need the negative anymore because he should be happy there. And I know that 4 squared is 16. So that's my final answer. Again, 4 squared, could have just thought of it as the reciprocal, and you're perfectly fine. All right, so let's look at the B. B was 6 to the negative 8 times 6 to the 8. Now there's two different ways to interpret this or do this problem, depending on what you notice first. I noticed that the bases were the same, so I can go ahead and do my product of powers property. Base stays the same. My rule is to add the exponents. Negative 8 plus 8 gives me 0. And any number to the 0 power is 1. Okay. Another way you could have done this, and I'll do it in a different color, is imagine these as being two fractions. One of them is not happy. So this guy is going to get rewritten so that he is happy. If 6 to the 8th is not happy on the top, then 6 to the 8th moves to the bottom. This one was fine the way it was. No negative exponent on that one. Now when I multiply straight across, I'm able to get 1 times 6 over 8 is 6 over 8. I'm sorry, 6 to the 8th. 6 to the 8th times 1 is 6 to the 8th power. And I do know that when I divide the same thing divided by the same thing, you get 1. But I can also do the subtraction rule here. 6 to the 8, take away 8, gives me 6 to the 0, which equals 1. Now I just did this both ways so you can see the variation and the different ways that you can interpret the problem. As long as every step that you do is mathematically correct, you can arrive at the right answer. Okay? So let's do C, which was 1 over 5 to the 7 times 1 over 5 to the 4th, negative 4. Now, with this one, I see that there is a power that is not happy, so I'm going to put him in the right place so that he's happy. So this is the one I'm going to fix. 1 over 5/7 is fine, no complaints there. But this one needs to be moved somewhere else. And this is why I was telling you about reciprocal, because reciprocal does mean that the numerator and denominator flip. And in that case, 5 to the 4th would go to the top, and the 1 would go to the bottom. But for some students, the negative, knowing when to get rid of it, is confusing, so that's why I came up with my story. 5 to the negative 4 is not happy here. So once he moves where he is going to be happy, there should no longer be a negative. He's content, okay? So now when we go straight across, this way you get 5 to the 4th, multiply straight across, 5 to the 7th. Now I can go across and say 5 to the 4th, take away 7. That's my subtraction rule because I have division of powers here, which leaves me with 5 to the negative 3, which is 1. This actually, think of this guy as being in the numerator right now. Not happy there. So it becomes 1 over 5 to the 3rd. And 1 over 5 to the 3rd is 1 over 125. Okay. Now, that's not the only way. I could have also done straight across. Too light. Let me get another color. I could have gone swoosh straight across, I get 1. Swoosh straight across, I get 5 to the 7 times 5 to the negative 4. And that rule tells me that I can add the exponents. 5 to the 7 plus negative 4. Which leads me to 1 over 5 to the 3rd. Which was the same thing I had here. So many different ways of doing the same problem. Again, as long as you apply the proper rules and you know what your step is correct, there's different routes and avenues in getting to that same correct answer. Right? There's no wrong way to do it as long as you get the right answer. And let's look at D. Four to the 5th times 4 to the negative 3 divided by 4 squared. So for this one, they're all bases of 4. So I'm going to work on the numerator first. And with that alone, I would get 4 as the base. I would get 4 as the base, and then I would add my exponents together. All over 4 squared. And then 5 plus negative 3 I know is 4 to the 2nd power over 4 to the 2nd power. You recognize that as the same thing divided by the same thing. You can jump ahead and just put 1. Or you can also have done 4 to the 2 minus 2 subtraction rule, which is 4 to the 0, which we also know is 1. Okay, so again, It all depends on what you feel comfortable in doing as your next step, as long as it's mathematically correct. And it's a true property that you're using, you're fine. E. Okay, so looking at this, I see a power that's not happy. Now, this one was a little bit of a challenge because you're thinking, oh, negative means reciprocal. Does it mean that the 3 to the second power comes to the bottom? No. Reciprocal would imply, oh, numerator and denominator switch. But we're not going to switch this time because that would mean 3 to the second power is happy right now. Why would we move 3 to the second power if it's perfect the way it is? And he's happy there. So that's why it's important for you to remember negative just means to move it somewhere else. So that little story is really helpful, as childish as it sounds a little, but this one's fine. Don't move it. This one is not happy here. If he doesn't want to be in the denominator, then the only other place he can go is in the numerator. Okay? And then if you got a gap there, you got a gap. Put a space holder. So now you got this on the top, right? 3 squared was fine, no complaints. But 3 to the 4th, we did not like it there. So we moved it to the top. Now that he's at the top, there is no negative there because he's happy. And so now we have 3 to the 2 plus 4 makes it 3 to the 6th power. And that would equal 9 times 1 is 9, 9 times 8 is 72, 729. Okay. And F. Okay. Now we got 3 things here. One of them is not happy. That's this x to the negative 1. X to the 3rd is fine where he is. But x to the 1st power is going to join them upstairs, right? It's going to join them in the numerator. And then this y to the 0 is still there. So now that I got everyone happy, no negatives anywhere, we're going to just combine these together. 3x is here, and one more here makes x to the 3 plus 1. This, anything to the 0 power, even including variables, to the 0 power, as long as that y is not 0, we got 1. And I forgot to mention, but we're going to assume it's not 0. Then you have x to the 4th. 1 doesn't change when you multiply it, so you're good. X to the 4th. And that is going to take quite a bit of practice to be comfortable with using all these properties, but hopefully this activity helped you out and clarified some of your confusion. We'll talk to you soon.